Dear friends, once again I welcome you all for another interesting session or interesting presentation on our control system subject. In today's presentation, I am going to solve some previous questions that have been asked in UPSC's IAS examination. Okay. So especially on time domain specifications, what are the questions asked in previous examinations? That we will see few questions. Okay, we will see. So by the way, this is our lecture number 37. This is our lecture number 37. So today we will see some examples on means previous examinations basically. So this is the question asked in UPSC IES 1999. What is the question? So the question is asked like this: the system with the open loop transfer function, the system, what is that? The system with the open loop transfer function. In simple, I can write as OLTF, open loop transfer function, instead of writing the complete sentence. Better to write open loop transfer function is given as G of S into H of S is equal to, it is 1 by S into 1 plus S. This is given. Is here the options are given. The first option, what is that? Type 2 and order 1 and order 1. That is first option. Next, B option is given. Type 1, what is? Type 1 and order 1 and order 1. And the C, third option, type 0 and order 0. And the last, fourth option, type 1 and order 2. So these are the options given. So you need to find out. This is the given OLTF, means open loop transfer function. G of S into H of S is equal to 1 by S into 1 plus S. This is the given problem. From this, you are asking what is the type number, what is the order number. I think in our previous presentation we have very much detailedly or very much clearly we have seen that. So for type number, I think you have remembered that. So from the given problem, if in the denominator polynomial, what we should do? So you must observe that s power n form. So normally you must remember that, okay, s power n. So you must see that in the denominator is there s power n into some s plus 1 or s plus 2, like that. In this form it must have. So then, so s is there here, s into 1 plus s is there, means, so what is n here? 1. Therefore n value is 1 here, 1 here, therefore it is type 1. It is type 1. Then what is the order? Order is nothing but both s into 1 plus s shall be multiplied. Therefore s into 1s plus s into s square. Then what is the highest order of that equation? If you multiply these two, that is s into 1s plus s into s square, means the highest order is 2. The highest order, the highest power of s, otherwise the highest power of s is the order of the system. So what is the highest power? It is s power 1, s power 2. Highest is 2, therefore it is order is 2. Therefore your answer is D. Option D is the answer for this question. It is a type 1 system, whereas the order is 2. Clear? So this is the question have been asked in IAS 1999. Okay, then we'll see one more example. We'll see the second example. So I remove this also. Okay, we'll see another example. So the open loop transfer function here, the similar problem, actually it is asked in IAS. It is asked in 2000. IAS 2000 it is asked. So the question is this: the open loop transfer function g of s is given. Clear? The open loop transfer function, always I will write like this: the open loop transfer function g of s is given as, what is that, 1 by s into same whatever we have seen, similar problem only. The OLTF is given like this, and this is subjected to an input of, means this g of s is subjected to and is subjected to an input r of t is equal to sin t. R of t is equal to sin t. Then find out the steady state error. Then find out, that is the question. Then find out what is ESS. What is the steady state error? So options are given. The first option is 0, and the second option is 1, and the third option is root 2 times sine pi minus t by 4. Clear? T minus sorry, it is t minus pi by 4. It is t minus pi by 4, and the D option is root 2 of sine t plus pi by 4. These are the four options given. A is 0, B is 1, C is root 2 times sine t minus pi by 4. The last option is root 2 into sine of t plus pi by 4. So, okay. So, here the given question is g of s is equal to 1 by s into s plus 1, and this is the open loop transfer function, and this open loop transfer function is subjected to the input r of t, and you are asking that ESS. I think in last presentation we have seen. Clear? It is very easy actually. So what is ESS? So solution. What is ESS? We know that the steady state error ESS is equal to limit s tends to 0 s into E of s. Clear? This is the definition we have seen in last presentation. That is again further, limit s tends to 0 s into E of s is nothing but r of s by 1 plus g of s into h of s. Clear? This is further. E of s is equal to R of s by 1 plus G of s into H of s. Okay, you just refer our previous presentation, there you will get in detail actually. Okay, this is what your E of s, E of ss. Then what is your R of s? R of s is nothing but input. So already it is given in the problem, the R of t, small r of t, I mean the input is subjected to sin t. Time domain function is given. Then R of t is equal to sin t. For this you need to find out the Laplace transformation. So if you apply the Laplace transformation to this function, means Laplace transformation of R of t is nothing but Laplace transformation of sin t. Clear? Sin t. So Laplace transformation of R of t becomes your R of s. Okay, after applying the Laplace transformation to the R of t, it becomes as R of s. Similarly, your Laplace transformation of sin t, what is sin t? What is sin t? Laplace transformation of sin t, what is that? So you need to remember all these formulas basically. So Laplace transformation of the standard, let us say sin omega t, let us say, then the Laplace transformation of sin omega t is equal to omega by s square plus omega square in general. But here in the given problem, so our function is given as sin t only, means sin t. What is the omega value here? If you compare this sin t with sin omega t, this is the standard form actually. Okay, this is the standard form. So if you compare this sin t with the standard, so here omega value is 1 actually. So nothing is there, means omega is 1. So in the correspondingly, wherever omega is there, you need to substitute 1. Therefore 1 by s square plus 1 square, it is 1. So it is 1 by s square plus 1. That is what the Laplace transformation of sin t. Understood? Laplace transformation of sin t is equal to 1 by s square plus 1. This is what your R of s basically. This is what your R of s. R of s is equal to 1 by s square plus 1. Therefore, you substitute that in the definition of ESS, 1 by s square plus 1. So, if you substitute that, then what you will get, ESS is equal to limit s tends to 0, clear, s into R of s by 1 plus G of s into H of s, clear, and further limit s tends to 0, s by, what is R of s? 1 by, what is that? S square, 1 by s square plus 1, no? S square plus 1 by 1 plus, what is G of s into H of s? H of s is a unity feedback system basically. It is given as unity feedback system. Unity feedback system, nothing but H of s is 1. Therefore, directly G of s value is substitute, that is 1 by s into s plus 1. Clear? So, furtherly you can substitute as, okay, here if you take cross multiplication, s into s plus 1 by s into s plus 1, okay, the everything means that everything, so this will comes here, no, s into s plus 1 plus 1 by this one. So in the numerator and denominator part, what you will have, s term is there. So after applying the s value, 0 value, then definitely it becomes 0 by 0 form actually. So okay, 0 by 0, or otherwise I can, you can write, no problem here. So this further if you simplify this, so you can keep this limit s tends to 0, it is 1 by some s into s square plus 1 by, simplify this, take cross multiplication. So s into s plus 1 by s into s plus 1. okay, s into s plus 1. So take this denominator to the numerator part. Okay, now then what you will get actually? What you will get actually? So finally you will get ESS after simplification. Basically this part goes to the numerator part, means s into this s will be there in the numerator, this s into s plus 1 again, therefore s into s will be multiplied, s square will come, s square into s plus 1, clear, s square into s plus 1, and in denominator it comes as s square plus 1 into the entire part will come s into s plus 1 plus 1. Now you apply the limitations now. So this is what limit s tends to 0. So if you apply now 0, apply 0, 0 wherever s is there, 0, 0 and 0. So 0 plus 1, okay, and then again 0, 0 plus 1 is 0. I mean 0 plus 1 is 1 here, but again it is 0 multiplied with. So everything it will become, however 0 by something 0, no? So your answer is 0. Therefore the answer for this is ESS, the steady state error, is equal to 0. So for this problem the answer is 0. Therefore you need to practice, actually you need to remember and practice the formulas, then definitely you will enjoy the control system subject and especially the time domain specifications. Okay, so the time domain specifications are the very interesting specifications, and you will expect definitely you will get problems in your UPSC as well as in your gate examinations also. And we'll see another example. It is a theoretical type. It is asked same in 2000, yes 2000 only it is asked. So the question is like this, it is a theoretical basically. What they have asked, a second order system has the damping ratio of, what is they have asked, a second order, okay, a second order system has a damping ratio of, a damping ratio of zeta and undamped natural frequency. What is undamped natural frequency as omega n? Okay, the settling time. Now the question is the settling time. The settling time at 2% of tolerance band. 2% of tolerance band is, the option is, they have given the options actually, 2 by 4, 2 by, it is zeta omega n, and B option 3 by zeta omega n, C option it is 4 by zeta omega n, and D option it is simply zeta into omega n. What is the this we have seen actually, it is a theoretical. Remember that this is a settling time basically. In our previous presentation we have seen, while studying the parameter of the settling time, so we have two types of tolerance bands. One is 2% tolerance band and second is the 5% of the tolerance band. For 2% of the tolerance band, the settling time is equal to, it is 4 by zeta into omega n. Therefore your answer is straightforwardly C. C is your answer. Clear? Whereas for 5%, the settling time is equal to how much? 3 by zeta omega n. These we have to remember definitely. So for 5%, the settling time is 3 by zeta omega n. For 2%, it is double actually, 4 by zeta omega n. Therefore, for this question, the answer is 4 by zeta omega n is the answer for this question. So it is a theoretical. There is no mathematical involvement here, calculations. So it is directly the theoretical question. Okay. And then next, if you see the steady state error for a step input applied, this is asked in 2001. Another question we will see, it is IES 2001. It is asked in IES 2001. The steady state error again. So the open loop transfer function is given. Directly I will give you the problem. G of s is equal to 10 by s square plus, it is 14s plus 50. So this is the direct problem actually. For this he is asking, the question is, what is ESS? Find out ESS. What is the steady state error for step input? For step input. For step input. So remember that in order to find out the steady state error, input must be given. Without input, you cannot find out the steady state error. Clear? So always remember, so ESS can be calculated once the input is given. Okay, either the input is step input or a ramp input or parabolic input. That input must be defined, that must be given in the problem. Otherwise, without this input, no, you can't. Therefore, here for this given problem, this is the open loop transfer function given as like this, and the step input is applied. The step input is applied. For the step input, what is the steady state error? That is the question. Okay, what we should do now. So what is step input first? The step input is nothing but u of t. U of t is equal to, we know, 1 for t is greater than or equal to 0, and it is 0 for t is less than 0. This we already seen. Clear? This is the step input. Or sometimes, as far as our control system subject is concerned, you can consider this as r of t also, because no, r of t is nothing but your u of t. Okay, so this is in general the standard form of representation of step input is u of t, but nothing wrong in that you consider u of t as r of t also. This is called 1. U of t is equal to 1, and same you can consider as r of t. Now if you apply the Laplace transformation to this, L of t of r of t, nothing but L of t of u of t, nothing but L of t of 1. Clear? L of t of 1. What is this? It is 1 by s now. This we have seen already in our previous presentation. So the Laplace transformation of unit step function, that is u of t, nothing but r of t as far as this concerned. Therefore, if you, for 1, the Laplace transformation is equal to 1 by s. Why? Because now you take the definition of ESS. So remember that your L of t of r of t is nothing but capital R of s. Clear? Capital R of s. Therefore, capital R of s is equal to 1 by s. This you must remember, and substitute the R of s equal to 1 by s value in the definition of the steady state error. So what is the steady state error? Clear? Just I am erasing this. What is steady state error? ESS is equal to limit s tends to 0, s into R of s by 1 plus g of s into h of s. Clear? This is the definition. Now, as for this definition, what is your R of s? R of s is required, no? R of s is your input. Step input is given. So for the step input, we have find out the Laplace transformation already. R of s value is 1 by s. Therefore, from here, limit s tends to 0. S is already there as per the formula. R of s value is 1 by s. Therefore, by 1 plus, what is this? G of s into h of s. G of s into h of s is nothing but what is this? 10 by G of s value is this one. What is h of s? Because it is a unity feedback system, unity feedback control system. Whenever the unity feedback is mentioned in the problem, assume that h of s value is 1. H of s is equal to 1. Therefore, so okay. Therefore, only you will have g of s value only, means 10 by what is that, s square plus 14s plus 50. Clear? Now this s will cancel out. Clear? So what we will have here, so I will write here. So ESS is equal to what we will have, limit s tends to 0. Already 1 cancelled out, therefore 1 by what is that, 1 plus 10 by what is that, s square plus 14s plus 50. This is what, no? Clear? So what you will get then? What you will get here? Substitute s tends to 0 here. Substitute s tends to 0. Then from here what you will get, it is 1 by, so there is no s term in 1, therefore as it is you will be, you just keep that, and plus what you will get, it is 10 by, 10 by means limit s tends to 0, apply s value is 0, therefore 0 plus 0 plus 50. This is equal to 1 by 1 plus 10 by 50. Clear? 1 by 1 plus 10 ones are 10 fives are, it is 1 by 5. What you will have actually, 1 by 5 into 1 plus 6, 6 by 5, or otherwise you can take 5 by 6. Therefore, how much it is? Clear? It will be reversed, no? So, it is 0.83 something. This is what your ESS. Understood? So, the limit value, how you applied? Clear now? So, limit s tends to 0 is equal to, means in denominator you have to apply that limit, because as numerator you don't have any s term, khali just you have 1 only. Therefore, limit s tends to 0 if you apply, as you have constant here, so constant, there is nothing to, there is no need to apply this limitation because it is a constant. Therefore, 1 plus, now apply limit value here. So, limit s tends to 0 means that wherever s is 0, s is there, you substitute s value as 0. S tends to 0 is nothing but s value should be 0. Therefore, 0, 0. Then 10 by 50 will be there. And finally, you take the calculation and finally you will get this answer. 0.83. That is the another beautiful example on this steady state error. Why? Because in last presentation we have seen steady state error, no, as well as the error constants. Therefore, you will get such type of questions in your competitive examinations. Clear? And then finally we'll see one more interesting example, which is very important model basically, and also asked in IAS 2011. So very important and interesting example we'll see. This is asked in IAS 2011. It is asked in 2011. What is the problem? You know, same actually. The open loop transfer function is given. The OLTF. The OLTF is given as the OLTF of it. The OLTF, open loop transfer function of a unity feedback control system, is given as G of s is equal to k by, it is k by, what is that, s into s plus 6. S into s plus 6 is given. S into s plus 6 is given. So now we are asking that find the value of k. What is that? Find the value of k. Find the value of k for the damping ratio of, what is, for the damping ratio, means for the damping ratio. What is damping ratio in general? Zeta, no? Damping ratio of 0.75. So for the 0.75, you need to find out what is the value of k. That is the question. So OLTF is given. OLTF nothing but open loop transfer function, and closed loop is nothing but CLTF. If you write CLTF, that is closed loop transfer function. Clear? So this is G of S actually. Remember that whenever the OLTF is given in this fashion, you need to write the characteristic equation in the very beginning. I think in the second presentation or otherwise in third presentation, I have already explained that the characteristic equation is nothing but 1 plus G of S into H of S equal to 0. If the denominator part equal to 0, then this particular equation is called as characteristic equation of a control system. Clear? 1 plus G of S into H of S equal to 0. Okay, this is called characteristic equation. Therefore, already you have G of S. Therefore, H of S is not given, means it is a unity feedback system. Therefore, H of S value became 1 here. Therefore, what you can do? 1 plus G of S, at least you can find out, no? Equal to 0. From this, what you will get? 1 plus, what is G of S? It is k by S into S plus 6. Make equal to 0. Then finally what you will get here? Second step, S into S plus 6 plus k equal to 0. This implies what you will get? S into S, it is S square, S into 6, 6s plus k equal to 0. This is the second order equation you obtained. S square plus 6s plus k equal to 0. That is the second order equation you got now. Now, what we should do is, this particular expression or equation must be equated with the standard form. What is the standard form? So this particular must be equated with the standard form. What is the standard form? So the standard form, we know that the standard form is nothing but S square plus 2 times zeta omega n into S plus omega n square equal to 0. This is the standard form. Always you must remember this. Nothing wrong, nothing difficult actually. All depends on practice only. If you do more practice, you will remember more. Okay, you remember more, and with efficiently you can remember. That's why we call it as efficient. So this implies, so this is the standard form. Now you equate this particular with this equation. So if you compare S square term, S square is there. Then S term, here the S term, what is the 2 zeta omega n? Therefore 2 zeta omega n is equal to how much? 6. 6 is there. This implies from here what is zeta is given. From this omega n can be obtained, no? Omega n is equal to how much? It is 6 by 2 times zeta. That is equal to 6 by 2 into 0.75. Actually, it is how much? It is 6 by 1.5 will get. 2 into 0.75 is nothing but 1.5 basically. So 1.5, how much you will get? So obviously it is a 4. You will get 4. Therefore omega n value is 4. Clear? Omega n value is 4. Then our aim is what? To find out k value, no? Therefore now, so S terms we have equated. Now omega n square is equal to k. Therefore your k is equal to omega n square. Clear? So I will erase for a moment. So k is equal to omega n square. Remember that. So okay, k is equal to omega n square. Clear? So omega n square. Therefore what is omega n actually? 4. Therefore it is 4 square. Therefore 16. Therefore what is k value? 16. That is your answer. Therefore k value is 16. Likewise, these are the few examples we have seen today, and in next presentation we will solve some more questions, okay, especially from this IAS and then GATE examinations, right? I think, I hope that you have enjoyed this session, and if any clarifications or any suggestions or any comments or any your observations can be, okay, without any hesitate, or feel free to ask and to post, and I will take it as in a positive manner, and definitely I will consider it as a challenge, and I will try to give my level best to reach you all. Okay, so I once again request you all that you can like it, and you can comment, and you can subscribe to this channel, and don't forget to share with your friends. Okay, so with this I finish off today's presentation. We'll meet you in next presentation. See you.